All right, here we go. So we got 6.1 bisectors. Okay, we've done bisectors before, but we haven't really done it with graphing and some of the theorems we're going to talk about today. So first thing we have to know is we have what is a perpendicular bisector, which we should have talked about a couple times at this point in the year, but just to make sure we're all on the same page, we'll talk. Okay, this symbol here we've used before. This means perpendicular. Which means they have to cross at 90 degrees. Okay, you'll see this symbol a lot. Okay, so what is a perpendicular bisector? All right, just make sure I don't mess this up. So the definition is a line or segment it's a line or segment that bisects another segment at 90 degrees. All right, it's got to be perpendicular, it's got to make 90, and it's got to cut it in half. Okay, that's what bisect means. Okay, so let's draw picture one. Let's draw a segment AB. So we got A, we got B, and we're going to draw a perpendicular bisector, meaning it's going to go through the middle. Okay, so we need a point M in the middle here. So it does have to be exactly the middle, otherwise it wouldn't be bisecting it. And let's draw a line like this, going through M. And we'll call this, put a point C on it, just so we can name it. Okay, now this is not a perpendicular, right now this is a bisector, but once we do this, then it's a perpendicular bisector. So we would say this. CM, so line CM is a perpendicular bisector. Let me just write it out so you know what I'm saying here. Is a perpendicular bisector of, what is it? Bisecting segment AB. Good. Okay, so that's what a perpendicular bisector is. Let's move on. Okay, perpendicular bisector theorem. Okay. Okay, so what does this mean? This has to do with isosceles triangles. So let's draw a picture here. And we're going to say this. I'll draw a picture first, and then we'll make an explanation. So let's say we have a triangle. Okay. We've got 3 points on the triangle. And let's say we have a line going up through the triangle like that. This will make more sense in a second here. Okay, what we're going to say. Let's say that we know that this is a perpendicular bisector. Okay, it's cutting in half and it's 90-degree angles. Then what must be true is that this has to be an isosceles triangle. Okay, so if this right here is a perpendicular bisector, then we can say, so same picture here, redraw it. Then we can say that these are congruent. Okay? So here's how I say this. If two segments of a triangle meet at a perpendicular bisector, then the triangle is isosceles. Then it is isosceles. And I don't have enough room. Then it is isosceles. Okay, so anytime we have a perpendicular bisector going through another point, it has to be the case that it's isosceles. All right. Now the converse, just essentially the same thing in the other direction, which is what converse means. So we're going to say if it's isosceles, then it has to go through it has to meet at a perpendicular bisector. okay? So let's draw another picture here. If, and we got a triangle, and we have a ray going up like that. So if we have an isosceles triangle, and we have a ray going through it, then it must be the case that that has to be a perpendicular bisector. So it must be true that this is a perpendicular bisector opposite. If it's isosceles, then that ray going through this point here has to be a perpendicular bisector, cutting it in half and make a 90-degree angle. Okay, good. So if a triangle is isosceles, then how can I phrase this? Then two segments must meet at a perpendicular bisector. Then two segments meet at a perpendicular bisector. Very good. Okay, so the problems you get with this aren't crazy. They're just going to test to see if you know it and just have you solve some simple equations based on this fact here, right? If it's perpendicular bisector, well, you can set these two equal because it's isosceles. All right, let's look here. All right, so we've got perpendicular bisector, and we're going to write the equation of it, okay? So we're going to start with this segment 0, 1, and 4, 9. And we're going to write the equation. Now, we've done this before. It's been a while. But all we're going to do is we're going to plug it into point-slope form. You can use slope-intercept. I'm going to use point-slope form, and we'll get our equation from it. Okay? So let's scroll down a little bit so we have our graph. And let's first start by drawing our segment, okay? You're not always going to get a graph for these, but you can graph it. I'll do one with a graph and one without so you can kind of compare. All right, so let's draw our segment. So we got 0, 1, and then we got 4, 9. 4, 9. All right, and I'm just going to connect those. Maybe you want to use a ruler. I've got a little straight edge tool here. Good. So go ahead and draw that. And I'll just call this point A, and I'll call this point B. How else we keep track? Okay, so if I want to bisect this, I need the midpoint, okay? So I need to find what's halfway between A and B left and right, and then what's halfway between them up and down. Now we are going to end up with some decimals here, but it should work out just fine in the end. Wait, make sure I graph this right. You know what? I'm a dingus. I was like, this is not looking right. Yeah, I messed up point A, right? Point A is 0, 1, not 1, 0. Okay, so if you were kind of looking at me sideways while I did that, I was wondering, something wasn't looking right. There we go. So now we have A and B in the correct spot. All right, now it's looking right. Okay, so now we're not going to get a decimal. So let's find the midpoint. So halfway between 0 and 4 is 2. So our midpoint is going to be 2 is halfway between 0 and 4, and half between 1 and 9. Well, that's going to be 5. All right, so let's graph this over 2, up 5, right there. I'll call that point M. Now, in order to find perpendicular, I have the midpoint. I've bisected it. In order to find the midpoint, or sorry, the slope, I need to find the slope of this, and then I find the perpendicular slope. So let's find the slope. You can just count the spaces. So we'll say this is the slope. I'll just label it as AB. All right, so my rise is up 8 over 4. So it's going to be 8 over 4, which is the same as 2. So that means my perpendicular slope, okay, is going to be the opposite reciprocal, meaning I flip it and make it negative. So I'm going to make this 1/2 and make it negative, so my slope is going to be negative 1/2. All right, I have everything I need. I just have to plug it into my equation, which is point slope form y minus y1 equals mx minus x1. I don't think we've used this in a while, but we did this a lot in chapter 3. Okay, so let's plug in our values here. I'm going to use my midpoint, so my y value is 5. So it'll be y minus 5 equals negative 1/2 and x minus 2. Okay, distribute, add 5, and we should have our answer. So we distribute negative 1/2 x, and that would be plus 1. Then I add 5, and I get my answer. Y equals negative 1/2 x plus 6. Now, if I did this correctly, I should be able to graph this, and it lines up exactly, making a perpendicular bisector. So let's check that before we do anything else. So my y-intercept is 6. My slope is down 1 over 1, down 1 over 1. And I can connect this, and everything is happy. It all lines up just like so. So this is my perpendicular bisector. It's 90 degrees, and it cuts AB in half. Okay, and they're going to ask you for the equation, which you need to use your point slope form for. Okay. All right, let's do it without a graph. Obviously, you can always grab some graph paper and do it this way, but it is quicker, and you are going to be expected to know how to do it without a graph. Okay, so let's look here. Here's our segment. We need to find our midpoint, our perpendicular slope, and then plug it in. All right, midpoint. So halfway between. Oh, wait, did I do the same points? I did the same thing, didn't I? Oh, this is the same problem. Well, hey, let's just make something up then. Oh, ding dong. Let's just make something up. Let's say that we have, I don't know. Let's say we have 3 and 10. Let's say we use this point here, okay? All right, so if this is our, no, I don't want to get decimals. Okay, pick one that actually works out nice here. Yeah, let's do this. Let's do 2. Let's do 2/9 instead. Okay, so let's do this one. Find our midpoint, perpendicular slope, all without using a graph. Okay, so half between 0 and 2 is 1. Half between 1 and 9, once again, is 5. So now...
Tanner Moss, Bella White, Myrie Callahan, and Kylie Ayers have to please come to the office.
All right, now the announcements are over. Really should have changed this earlier. I thought I did change this, but I guess I didn't. Okay, my rise is 8. My run is 2. And that means my slope's going to be 4, which means my perpendicular. Oh my gosh.
Myrie Callahan, Kylie Ayers and Layla Dumbler, please come to the office.
Okay, hopefully that's the last announcement. All right, so my slope, my perpendicular slope I want to use is negative 1/4 x minus x1. So I just got to plug in the points for my midpoint. I get y minus 5 equals negative 1/4 x minus 1. I got negative 1/4 x plus 1/4. All right, we're going to get a messy answer here, and that's okay, but you need to know what to do if you run into fractions. That's going to happen more and more. All right, so I got to add 5 to 1/4. Okay, not the end of the world. I do want your answers as improper numbers. Okay, so I got to do 5 plus 1/4. I don't want you to just type this in your calculator or do a decimal. You can, but I want you to get in the habit of using fractions. Okay, so this is really 5 over 1. I need a common denominator of 4. So I'm going to multiply the top and bottom by 4. So it'll be 20/4 plus 1/4. And I get 21/4. So my final answer will be y equals negative 1/4 x plus 21/4. If you wrote this as 4 5 1/4, that would be fine. However, as we get further into the year, that's not always going to work. Okay? So that'd be your answer. All right, had to change problem a little bit, but there you go. That's how you do it without a graph, which is what I'm going to expect you to do. All right, angle bisectors, okay? You need to know, first of all, you should know what an angle bisector is, but let's just go over it quick. An angle bisector means that we are cutting an angle in half, okay? So angle bisector means that you're taking an angle and you're making a third ray in the middle that cuts it perfectly in half, right? If it was 60 degrees, you cut it into 30 and 30. So why is this important? If, we're going to draw another picture here. If we have a bisector, okay? So let's say we have an angle that's being bisected, so it's being cut in half. Then what we can do is we can make perpendicular segments, and those have to be congruent. Here's what I mean. Then it has to be the case that if we have, okay, so we have our some point on there, it has to be the case that if we do perpendiculars that meet at some point on that bisector, they have to be congruent. They have to be the same distance, okay? And that's because this is perfectly in the middle, okay? Anytime you have something in the middle, it has to be equal distance from both sides. All right, so let's write down our definition. If an angle is bisected, if an angle is bisected in the perpendicular, then the perpendicular segments from a point on the bisector are congruent. Okay? If it's being bisected, from any point on there has to make congruent perpendiculars. All right, now something you need to understand that's gonna, in this unit is more and more important, is the shortest distance, the idea of shortest distance, okay? If I throw a ball, okay, and at any point it's in the middle of the air, what is the shortest distance to the ground, okay? Because that's kind of what this is gonna be used for in a little bit here. What's the shortest point on the ground that is closest to this ball, okay? Well, it's gonna be straight down, right? The distance straight down from this ball, that's gonna be the shortest distance. Now, that is always gonna be a perpendicular, make 90 degrees. So the idea of a perpendicular is that it makes the shortest path to an object, okay? In this case, it's the shortest path to this dot here, but you'll start to see problems that use that in different ways. All right, converse to angle bisector theorem. Okay, same thing, but in reverse. Okay, so if we have, we're going to have a point here, and if we had two perpendiculars are congruent, just like that, then it must be the case that it's a bisector. It's an angle bisector. Then it must be true that that's bisecting the angle. Okay, so here's how I say this. We would say, if, make sure I get this right, if perpendiculars from a point to rays are congruent, then the ray is an angle bisector. Okay? All right. I think that's it. Yeah, that's it for 6.1. Like I said, they're going to sort of use this idea of distance. Maybe not a ton of 6.1, but more so later on in the unit. But that's it. We got perpendicular bisectors, angle bisectors. They're going to make segments congruent, right? Because they're bisectors. Okay, that's it. Have a great day. I'll see you next time.